Welcome to Section 2, Skeletal Rigging for a Realistic Human Character. In this section, we're going to do a basic rig using position constraints. For this, you're going to need some control objects. You can use nulls because really the center is the only important thing. However, nulls are hard to select. Cubes or spheres might be easier. Cubes are going to give you the least geometry and are probably better to use than spheres. Some people don't even like to use geometry at all. One thing you can do is go to magnet on point, and then draw a linear curve. This allows you to get the same shape as a cube, but you don't have any geometry involved. At this point, you want to bring your model in, and you want to put the parts of your model under a single null. If you have a simple character, putting all the parts under a single null is fine. This will allow you to toggle their visibility off easily, and later on you want them under one null when you do your global envelope. You can also put different sections under single nulls if you want to envelope them separately from each other. In this case, I put the body under separate nulls from the hands, the head, and the hair. The last thing you want to do with the model is you want to toggle the selectability of the model off. Just select the object and go to Selectability under the Selection menu and toggle it. That way we can pick our control objects easily. I've placed my first cube in the upper chest area where the neck begins to bend. I'm tagging the points so you can see it a little more easily. Then I'm going to name it. I'm going to name this cube chest, and I'm going to name every control object that I make so that I can find it in the schematic view. I'm going to duplicate this first cube and translate it over to where the shoulder starts to bend. This is the first shoulder cube. Then I'm going to duplicate it again and translate that one to the upper part of the main shoulder bend. The reason I make two is because if you make just one shoulder cube, the shoulder collapses quite a bit when it bends. This keeps the integrity of the shoulder even when it bends. Then I'm going to duplicate this again and translate it over to where the wrist is going to bend. You want to look in all your views to make sure you're placing these correctly. Then you want to name each of those cubes and symmetry them to the other side. If you do symmetry, however, it's a good idea to freeze the rotation. This sets your center back to normal. Then you want to select the chest cube again, duplicate it, and translate it straight up in Y. You want to also look in the right view. You want to place this where the head is going to rotate. Then duplicate that cube and translate it down in Y. And you want to place it in the center of the pelvis. Then duplicate it again. And place it on each side where the leg is going to bend. Then you want to duplicate that cube and translate it down to the ankle area. You want to place it where the ankle is going to bend. Then do a symmetry on that. This is the last of all the main control objects. For the rest of them, we're going to use nulls. Here I've got a null. I'm going to place it at the top of the head. Then duplicate it and place that at one of the elbows. You want to place it behind the elbow. You can symmetry that. Then duplicate those and place them at the ends of the fingers. You want one for each set of hands. Then duplicate that and place it at the end of each toe. Lastly, you want to place a null in front of each knee. Okay, that's all your control objects. Now you want to hide your model, and we can draw the skeletons just using the control objects. Now that we have all the control objects in place, we want to draw skeletons from the center of control object to the center of another control object. We're then going to connect these together with the control objects and constraints later on. To begin with, in the front view, we're going to draw all the one joint chains first. So go into Actor, go to Skeleton, draw a 2D chain, and we're going to start by drawing one from the center of the chest cube out to each of the shoulders, and to the head. Then you want to draw a one joint chain from the center of the first shoulder to the second shoulder. Then you want to draw another one joint chain from the center of the head 1 cube to the head null. Then you want to draw a one joint chain from the center of the wrist out to the hand null. Then you want to draw a one joint chain from the center of the hips to each hip cube. Alright, so that's all the one joint chains that we're going to draw in the front view. The rest of the chains we're going to have to draw in the top or the right view in order to be able to get the correct default bend. The first two joint chain we're going to draw is for the arm. We want to draw it in the top view so we get the correct default bend towards the back of the elbow. This is also going to be a two joint chain, and you're going to want to draw it from the center of the second shoulder cube out to the elbow null and back to the wrist. You can see how it has the bend towards the back, towards the elbow. Now you're probably going to have to adjust the length of this bone. If you didn't make your arm completely straight, then you're going to have to rotate it down into place. And it may not line up exactly with your elbow. If you have to change it, you can scale it on X, but you have to make sure that you freeze the scaling afterwards. Otherwise you'll get problems when you envelope it. Or you can use skeleton, move joint, or move branch. In this case, I'm going to scale it back a little bit so it fits correctly with the elbow. So I'm going to use move joint, pick joint by mouse, and just grab the joint and move it a little bit. After you get that in place, you can use Effect Symmetry to get the other arm. The next chains we want to do, we have to do in the right view. We're going to do the legs and the feet chains. You have to do them in the side view in order to get the correct default bends. Again, they're probably not going to be the right length if your legs aren't completely straight. And we're going to do a 2-joint chain for the foot too. You're going to then want to go into the front view and translate these into place and rotate them into place. We can then just duplicate that chain and translate it into place. Lastly, in the right view, we want to draw a 3D chain for the backbone. We're going to draw it from the center hip cube out towards the back and back in towards the chest cube. A 3-joint chain should be sufficient for the backbone. Okay, that's the last of the skeletons that we're going to draw for this rig. Try to make sure everything is the right length, and if you scale anything, make sure you freeze it. The next thing we're going to do is set the constraints on these. So I want you to go to Skeleton and turn off Show Critical Zone so you don't see those blue lines and we don't accidentally pick them when we're doing the constraints. To hook all our skeletons together into a rig, we're going to use position constraints to the control objects. Now a skeleton is made up of 3 parts: a chain root, which is a null, the joint itself, and then an effector, which is red and is also a null. All of our constraints are going to be on the roots and the effectors. It's best to zoom in on the front view to do this and have your schematic view open and be zoomed in on your skeletons in order to make sure you're picking the roots and the effectors. Okay, so let's do one of these. I select the chain root for the first chain here. It's for the chain that's going from the chest to the one shoulder. I'm going to select the root, go to Constraint, Position, and I'm going to click on the chest cube. Now if you turn on motion mode in the schematic view, you'll see a yellow line representing the constraint. Then I want to select the effector and go to Constraint Position again and click on the shoulder cube. You can see it pop into place, and you can also see the yellow line coming off of it. Then I'll go to the next one and do the same thing. I'm actually staying in constraint mode unless I hit the right mouse button. So you have to be careful when you're doing this. When you're picking things, you have to remember to hold the space bar down. And if you have a big rig and it's slow, you want to wait a few seconds and make sure you see it change on the status line. That way you won't accidentally constrain to something that you really just mean to pick. If you do accidentally constrain something, you want to go to Constraint, Relax, and relax that before you go on. You're going to get a lot of constraints and you don't want to have to go find it later on. So I'll just click on the chest cube for this one, and then I'll select the effector, and I'll click on the other shoulder cube. Then I'll do the next one, clicking on the chest cube, and then clicking on the head cube. And I'm going to keep doing this until I have them all constrained to the proper cubes. When you get to the head joint, you want to do the same thing, only you're doing it to the null. Same thing with the hands. Do the same thing with the hip cubes. Then, after you finish with all the one-joint skeletons, you want to do the two-joint skeletons. Start with the arms and do the same thing. Do the roots to the shoulder cubes and constrain the effectors to the wrist cubes. For the legs, constrain the roots of the legs to the hip cubes. And constrain the effectors to the ankle cubes. The feet, you want to also constrain their roots to the ankle cubes. And constrain their effectors to the toe knolls. Lastly, constrain the root of the backbone to the hip cube and the effector to the chest cube. With all your constraints done, your schematic view is going to look something like this. You should see yellow lines going from all the roots and all the effectors to your objects. You might want to go into the ruler icon and turn on for selected items only, fit to window ratio, and also compact empty areas. For this next section, you also want to put on grid lock because we're going to do our hierarchy. Now you can see that the yellow lines only go from the objects that I have selected. Just doing constraints to your control objects is not going to make a rig. The most important thing about a rig is how you set up your hierarchy. In this case here, all of the black nodes in the schematic view are different cubes that I have constraints to. The green nodes are the nulls, which I placed already in the hierarchy. In this case, the right and left toe and the top of the head null. I also have nulls for the elbows and the knees, which I'm going to use as up vectors later on. In addition, I've put in some other nulls, which I've colored blue here, which are going to add functionality to the rig. So now you want to put these into a hierarchy. It's best to put grid lock on, as I mentioned earlier, first. Then you want to get a primitive null, and I called it the shoulders null, and you want to make that parent to both the right shoulder and the left shoulder. Then you want to select each right and left shoulder and make it parent to the second part of the shoulder. Then you want to select the second part of the shoulder and make it parent to the wrists. The wrist needs to be parent to the elbow null and the hand null. Next, select the chest cube and make that parent to the shoulders hierarchy. You want to get another primitive null and name it neck and move it up so that it's in the area where the neck is going to bend. You want to make the chest cube parent to this null. Then you want to make the neck null parent to the head cube and the head cube parent to the head null. You also want to select the hips cube and make it parent to the right and the left hip. At this point you want to get another null, Place it where the waist is, call it waist, and make it parent to the whole chest hierarchy. Then you want to get another null, place it anywhere in the middle of the body. I called mine up body for upper body, and you want to make it parent to the waist chest hierarchy and the hips hierarchy. Next, get a primitive null, name it feet, place it in between the two ankle cubes and make it parent to the two ankle cubes. Then make each ankle parent to the toe and the knee null for each leg. Lastly, get a primitive null and put it somewhere in the middle of the body and call it all CNS for all constraints and make it parent to the entire upper body hierarchy and the feet hierarchy. Now your basic rig is pretty much complete. The next thing we're going to do is test this out. Before you global envelope your character, you're going to want to test out your rig to make sure it's working properly. Before I do that, however, I'm going to go into the spreadsheet. I want to go into multi-mode, and I want to select all of the chain roots. And all of the effectors. Then I'm going to set a name selection by going to Select, Set Name Selection, and type in a name. Hit Create. Then go back to your schematic view, and you should see a large node which represents that name selection. If you double-click it, it will select all of the roots and all of the effectors, and then we can just hide them. We don't really need those because they're all being constrained anyway. The key to using this rig is selecting things as branches and knowing when to rotate or translate them in order to get the best effects. For instance, I can select from the second shoulder cube down and rotate it in Z to rotate the arms down. Or I could select from the shoulders null and translate that up and down in Y in order to make him shrug his shoulders. If I select from the chest cube down, then I'd probably use rotation in Y to rotate the entire upper hierarchy. If I want him to bend over at the waist, I'll select from the waist null down and rotate that in X. If I want the entire character to go up and down, I'll select from the upper body null down, which gets also the hips, and translate that up and down in Y. The feet don't go through the floor because they're on a different level of the hierarchy. If I want to bend the neck, I can select it from the neck down and rotate that in X. Or rotate it in Z. If I want the head to nod, I can select it from the head cube down and rotate that in X. Or Z. If I want the hips to rotate, I can select the hips hierarchy and rotate it in Z as well. If you wanted to be able to select both feet together, you would select from the feet null down, and then you could make the character either jump or put his feet up. Or you could select from the ankle down and just translate one foot. You could also rotate that in X to rotate the foot. Now there are some limitations on this basic rig that we'll address in the advanced rig. One of them is if you translate a wrist The hand doesn't necessarily follow in the right direction. You have to rotate that into place. Also, you're going to notice some limitations on the backbone as far as rotating in the y-axis and in rotating actually the bones themselves. You'll notice the same thing in the head. If you try to rotate it in Y, the bone actually doesn't rotate because it's position constrained only. In the advanced rig, we'll use an expression to connect the rotation of the bone to the rotation of the cube. Now we want to global envelope our character. First unhide your character and then go into the schematic view. All of the pieces of your model should be in one hierarchy, and you may want to put an extra null above that whole hierarchy. When you do a global envelope, the skeletons come off the top null. If you want to be able to select all your models without selecting the skeletons, if you put an extra null there, it'll make it easier for you. So to envelope, you want to select your whole hierarchy, make sure all of your skeletons are in view, and then go to Skin, Global Envelope, and click on each of the skeletons. Just say OK to the dialog box. Now one thing you don't want to do is put all of your skeletons under a null. That'll make the null into a skeleton and it'll get points assigned to it when you envelope it. This can be undesirable unless you put some kind of special constraint on that null. There is a more complicated way that you can envelope your character. If there are certain pieces that you don't want to interact, you can envelope them separately. For instance, here I've got the head of the character, and then I've got the hair. Now if I don't want to go to the trouble later on of separating out the weights between the hair and the head, I could envelope them separately. However, both of them need to move the same way off of this same bone. So the way to do this is to duplicate this bone and once you have two of them, you can assign the head to one and the hair to the other. I've added a few other things to this particular character. Here's some hair chains that I've added to assign the hair to. I've constrained the roots of these chains to the top of the head null. I've constrained their effectors to nulls down below the head here, and I've made a parent to them so that I can scale them or translate them together. To add this new bone into the control hierarchy, you're going to want to do the same thing as you did with the other one. Constrain the root to the head cube and constrain the effector to the head null. That way it will move the same as the other one does. If you do decide to envelope your character in parts like this, make sure that you have these overlapping bones in the key areas, and make sure that you separate out the different model parts. You can place a null above them too, so it makes them easier to select as a whole. And also make sure that things that you don't want to deform are not part of the model envelope. In this instance, my eyeballs and my teeth are not going to be part of my envelope. So then to global envelope these, I'll do the same as I did before. I'll select the model, and in this case I'm going to envelope it to these two bones. I duplicated both of these bones because I also needed a neck bone for the body since I'm separating the head from the body. So I'm going to select the model, go to Skin, Global Envelope, and click on the two bones. Then I'm going to select the model for the hair and click on all the bones associated with the hair. And I'll keep doing this until I get all the models assigned to the correct bones. Then I'll hierarchy everything under one null. You may also want to separate the hands out from the body since we're going to be adding fingers and things to them later on. You can do it in the same way by just duplicating the hand bone, assigning it to both the wrist cube and the hand null, and then global enveloping it to the hand. After you envelope all the parts of your character, you want to put everything under one null, all of the skeletons and all of the models. Before we start going into the lengthy process of reweighting points, you want to move your model around a little bit and make sure that the bones are positioned correctly and that the bending is as good as it can get without reweighting the points. Here, if I translate the shoulders up, you can see that I'm getting a problem in the chest area. The points are moving too much. This is the kind of problem that you'll want to reweight points for. In this case, this is a segmented character, and I have a seam here between the chest and the stomach area. I need to make sure that seam is weighted 100% to this bone on each of the pieces. So I'm going to tag the points on the edge of the seam on all the pieces that border this seam. Once I get all the points tagged, I'm going to go to Skin, Envelope Assignment, Reassign Manually, and I'm going to click on the bone. The second way of reweighting points is called modifying the weights, and we'll want to use this to adjust the chest points so they don't move so much when the shoulders shrug. To do this, you want to select the pieces and you're going to tag points again. In this case, I'm going to tag these two rows. Once you have the points tagged, go into multi-mode, select all the pieces, and go into Skin, Envelope Assignment, Modify Weights. You're going to get a dialog box which has all the points that you have tagged in it. We're going to do this for all the vertices, not selected vertices. You want to find that bone, and when you click on it in the list, it gets highlighted. Then to keep those points from moving when it shrugs the shoulders, we're going to assign them a higher weight to that bone. Let's try 85%. You can still move the timeline while you're in here, so if you've saved keys, you can adjust it and see what it looks like. That looks okay. That's moving much more naturally now. Let's say at this point I decide I need another bone in my envelope, that I want one running straight down the hips here so that I can assign points from the seam of each leg to that bone. Now the problem with adding this bone is that it's going to reassign all my points again. Now, however, with 3.8, you can save out your point weights to a file. To do this, select the envelope, then go to Skin, Weight Copy. You then tell it where you want it to place the file, say OK. It asks you to pick a skeleton element. I'm going to click on the backbone. Now with that file saved, you can proceed to global envelope the new bone. You can see after I've global enveloped that new bone that I lost the weighting that I did in the chest area. To get that back, select the envelope again and go to Skin, Weight Paste. Select the file you saved, say OK, and click on the backbone again. Now you can see that the weighting in the chest is back to the way it was before I added the bone. Another constraint you're going to want to use in your basic rig is called an up vector constraint. This constraint is used mostly with skeletons and controls the Y orientation of a particular chain. We're going to be doing this constraint on the first joint of the arm bones, and we're going to be doing it to the null that we made for our elbow that we never constrained anything to. Depending on how you drew your chain, it's either going to be in front of the arm or behind the arm. It's all based on which way the y-axis is pointing. In my case, my y-axis for the first joint is pointing towards the front, so mine are going to be in front. You select the first joint of the chain, go to Skeleton, Up Vector CNS, and click on the null. Now if you select the null and translate it around, you'll see that it adjusts the orientation of the chain. Now in order to get this to work all the time, you're going to have to animate this null. I placed this null as child to the wrist cube so it moves with the wrist. But there are times when the wrist isn't going to be placed correctly according to it, and you're going to have to animate it manually. Another way of adjusting it is to use what's called the chain behavior effect. This is new in version 3.8. The chain behavior effect is a custom effect that automatically updates as your animation plays. It involves the up vector constraint and an object to track, which in this case is going to be the wrist cube. First go to Skeleton Chain Behavior. Make sure there's nothing in this box and say Load. It asks you to pick the object to track. Click the wrist cube. Then pick the up vector constraint. You'll see it creates an icon. In order to make this work, you have to detach the effect so you can teach it where to move the up vector according to where the wrist cube is. So with the effect icon selected, go to Motion, Effects, Custom, Detach Effect. Then as you move your arm around, I have some animation on my wrist cube here. Translate the up vector null to where you want it and do a Save key, Add Control key. Once you've done that, select the effect icon again, go to Effects, Custom, and reattach the effect. Then when you move the timeline, you'll see the up vector tracking the object automatically according to the keys you saved. Other things you might want to use up vectors on are the knees, and in this case possibly the hand. You may want to control the rotation along the x-axis of the bone for the hand by using an up vector. In this case, if I translate this, you'll see it rotates the hand. That'll also keep the hand from twisting. You want to make sure you put that in the hierarchy. You can make a child to the wrist cube. Incidentally, speaking about the hand, we still have this problem of the hand remaining straight whenever you move the wrist cube. One way you can do a quick fix on that is to go into the schematic and cut off the fingers null. Then go and find the effector for the arm bone and make it parent to the fingers null. When it asks you to make it part of the skeleton, say no. Now when this moves, it stays oriented in the correct manner. Here's a technique that you might find useful for animating certain parts of a character. In this case, I've gotten a simple square. I've added a couple of points to it. And I've tagged the points and moved them until they're sitting on top of the cubes for the wrists and the ankles and also the two up vectors. In this case, I'm not using the chain behavior effect. I've also tagged several of these points already and set clusters on them. In this case, I'm going to do the same with this one, Shape, Set Cluster, and hit New. Then I'm going to go to Shape, Cluster List, and you can see the different clusters that I have here. I'll make this one active, say OK, and then I'll select this up vector and do a constraint object to cluster. I'll click on the curve and you can see it pops to the curve. Go to Shape, Cluster List, select the next one, say OK, then select the next up vector. You should still be in constraint mode. Click on the curve, it pops to the curve. Select the curve and do it again until you have all of the pieces constrained to this curve. Once you get them all cluster constrained, you can shape animate this curve to animate the 4 limbs. Once you get all the cubes for the limbs cluster constrained to this curve, save a shape key. Then you can move the points on the curve around. And save another shape key. After you get the limb movement done, then you can select the cubes themselves and start adjusting the secondary motions. You're almost at the point where you can bring this basic rig into your scene and animate it. However, there's a couple of things you have to do first. You want to get a primitive null, and you want to make it parent to the entire skeleton model hierarchy and the entire constraint hierarchy. You don't want anything left out, because when you bring this into your scene, you may need to scale it or something like that, and you need to have everything under one null in order to do that successfully. Actually, once you've gotten that one null over your entire hierarchy, you're going to want to duplicate it. In this case, I've got 4 nulls above my hierarchy. This is called layering. You do this to have additional functionality when you're trying to move your model around. If I was putting this character on a path, I put another null up here and place that on the path. Then I would use this null to move with explicit translation if I wanted him to come off that path. Then I have 3 rotation nulls. If you've ever tried to rotate something in more than one way, the result is sometimes unpredictable. It often works better to have 3 identical nulls right on top of each other and do the rotation on the separate nulls. You may also want to do this in other areas of your hierarchy, especially in the control hierarchy, where you may be rotating in more than one way. The last thing I'm going to show you in doing the basic skeleton rig is a simple eye control using direction constraints. The first thing you want to do is on your eyeballs themselves, make sure that the x-axis is facing towards the front of the eye. Direction constraints constrain the x-axis to another object. So you want to make sure that they're rotated in the correct direction, otherwise they'll flip around. Next, you want to get 2 primitive nulls and place them right in front of both of the eyes. Then get another object and place it in between these two nulls. You can use a null, or in this case I'm using a square which I've colored orange. You want to make that object parent to the two nulls. Then you want to select each eyeball and do a direction constraint to the null which is in front of it. You should see a dotted blue line going from the center of the eyeball to the null. Once all that is done, you can select the control hierarchy and translate it through space. You should see the eyeballs tracking the control hierarchy. You can also scale that and save scaling keys. Or you can rotate that and save rotation keys for a more cartoonish effect. You could even position constrain this to another object in the scene so the eyeballs track that. This concludes section 1, creating a basic skeleton rig. The first thing we're going to look at is how to control the spine of our character by using virtual sliders. To do this, we're going to use expressions, so it might be best to do a simple review of basic expressions. Expressions are custom constraints that allow you to connect any aspect of one object in Softimage to any other object in Softimage. For instance, I have here a square and a circle. I'm going to connect the circle's scaling to the rotation of this square. So I'll select the circle and go to Expressions Edit. Inside the Expressions Editor, you can see that I have circle 1 as the affected element. I'm going to go into F-curves and select its scaling in X. Then I'm going to go onto the Expressions line and I'm going to go into Scene Elements and click on the square. And I'm going to connect the scaling in X of the circle to the square's rotation in Z. So I'm connecting the scaling in X of this circle to the rotation in Z of the square. Now in front of this equation I'm going to put 1 plus. Now we're dealing with scaling here, and this number in front is where that scaling is going to start out at. 1 is the normal scaling in X of that object. If I put it down to 0, it would squash it until there was nothing left of it. Plus or minus is going to scale it in a particular direction in X. If it's not the direction I want, I'll come back in here and make this a minus. So I'll say OK to this. Now if I select the square and I rotate it in Z, now it's doing too much scaling. If I want to decrease that, I'll go back into the Expressions Editor and I'll divide that using a slash symbol by 50. I'm just going to put numbers in here. If it's enough, then I'll leave it. If it's not enough, I'll make it more. If it's too much, I'll make it less. Dividing it's going to make it scale less. If it was going too little, I would put a multiplication symbol in there, and that would make it scale more. So that's really all you need to know at this point about expressions. You're going to start it out at a particular point. You want it to go in either plus or minus direction. And if it's too much, you're going to divide it. And if it's too little, you're going to multiply it. So I'll say OK to this, select the square, and rotate it in Z. And you can see it does it much less. So rotating clockwise scales it down, rotating counterclockwise scales it up. Maybe I want the opposite of that. Then I would go back in and change that to a minus. And now it's going to do the opposite. Now maybe I want this to always scale up instead of scaling down, no matter if I rotate it clockwise or counterclockwise. For this, all you put is ABS and quotations around it, validate it, and say OK. Now when I rotate the square, you can see that it always scales down whether I rotate clockwise or counterclockwise. If I wanted it to always scale up, I could simply change this to a plus sign. Okay, with that said, let's go look at the backbone. Here you can see I have a basic character that has a backbone similar to the one you have on your basic rig. There is a difference though. One thing your basic rig couldn't do is bend the backbone in all directions like this. The reason it can't do that is because of the default bend of the skeletons are locked into place whenever you use inverse kinematics. In order to change that default bend, you have to use expressions on your character. You may also notice in the front view that I'm controlling this character through virtual sliders, rather than by just picking the control objects themselves. This is also done through expressions. The chess cube here has to go left and right or back and forward, but it also has to go up and down in order to move on an arc. If you see, when it bends to the back or to the front, it's not only going front and back, but it's also going up and down. Same thing with to the side. It's going down as well as side to side. This is going to give realistic movement. It can't just go from side to side or front and back. It has to go up and down too. We talked about layering in the previous section. That's what we're doing here with these two top nulls. These nulls are actually controlling up and down motion. The side to side and the front to back motion is on the cube, but the up and down motion is on these nulls, according to it going forward or backward or side to side. The cube itself controls the side to side motion of the character as well as the forward and backward motion. But to get the realistic bending over like this, you also have to have an up and down control. If I select the first null, you can see that it goes up and down according to the forward and backward motion of the character. It doesn't go up and down if the character moves to the side. The second null goes up and down if the character moves to the side. Because these are parented, they also control the motion of the cubes as well. Now let's look at the bones themselves in the backbone. We're controlling the rotation of these bones according to expressions. That's changing their default bend and allowing the character's backbone to bend in all directions like this. If we go to Expressions Edit, inside the Expressions Editor you can see that I have 3 expressions on this backbone. The first one is connecting the rotation in Y of the joint to the chess cube's explicit translation in Z. I'm multiplying it by 15 and I'm using a 1 minus. All of this is particular to my character. Yours may be slightly different depending on the size and how much motion you're going to want. If we look at the next one, we can see that the rotation in Z of the bone is being connected to the chest's explicit translation in X. This is allowing him to bend over to the side. The third one, we're connecting the rotation in X of the bone to the rotation in Y of the chest. In this case, we're not controlling any bending over of the torso. This is the swiveling of the torso in Y. The length of the bone is always the x-axis of a bone, and that's why we're connecting the rotation in X of this bone to the rotation in Y of the cube. Let's select the next bone and look at it. You have to look at the centers of these bones as according to the center of your cubes. They're not the same. In this case, Z is coming towards me, Y is to the side, and X is the length of the bone. Keep that in mind when you're doing these expressions. Now inside the expression editor on the second bone, you can see it's the same as the first bone. I actually copied the first bones over to the second bone. The only difference is I'm multiplying it by a little less here. I was multiplying it by 15 on the first bone, and this one I'm doing it by 12. That's just going to give it a little less bend on the second bone as opposed to the first bone. For the third expression of swiveling the torso, connecting the rotation X to the rotation Y, I'm actually dividing this one a little bit to make it a little less. The first one was 1 to 1. This one I'm dividing it by 2. Again, this is going to make the bend a little less as you go down the torso, because we're controlling it from the chest cube, and these bones are further away from the chest cube. This is going to create a more natural bend. We're going to do the same thing with all of the other bones, decreasing them as they go away from the chest cube. If we want to see what that swivel rotation movement looks like in Y, I can select my slider over here and translate it. You can see it just swivels the torso in Y. At this time, the head is not connected to this. Okay, so let's connect the rotation of this head bone on its x-axis to the rotation in Y of this head cube. To do that, I'm going to select the head bone, go to Expressions, Edit. So I want to connect this joint's rotation in X to head 1's rotation in Y. It starts out at 0 and it's going to go in one direction or another. If it's not right, I'll come in and put the negative sign in it. Now if the head cube rotates in Y, you should see the head move, which it does. We also want to do that with the neck bone. And then since I don't want it to go so much, I'm going to divide it by 3. Now if I select the head cube and rotate it, I should see the neck bone rotating a little bit also. Now that I've done that, I want to make a virtual slider for that head movement. Here you can see in the schematic view are my virtual sliders. It's just a square and a null above the square. You need a parent to the object you're actually moving, in which case is going to be the squares. I'm moving these in X on this guide that I have here, which is just another square scaled down. The reason you need a null parent above this square, because if you didn't have a null parent, the expression would be using global parameters. If you have a null parent, it's using parameters that are relative to that null. In other words, I can move this anywhere I want in the scene rather than leaving it at the 0, 0, 0 axis. It's seeing the null parent as the 0, 0, 0 axis for this square, so that when it moves to the right of this null, it's giving it positive numbers, and when it moves to the left, it's giving it negative numbers. Otherwise, I would have to have all my sliders right on top of each other at the 0, 0, 0 axis for the global parameters. Once you have your three pieces here, the guide, the null parent, and the square, then you want to put some position limits on the square. Go to Constraint, Position Limits. Inside the dialog box, you want to use Box. Click on all the parameters. And in my case, I'm going to use a negative 13 and a positive 13 in X. And all the rest are going to be 0. This is going to allow my square to move negative 13 units left, positive 13 units right, and it's not going to be able to move up and down off of my guide. It's according to an object. You can set some damping if you want to, say OK, and then click on the guide. Now, no matter how I drag it, it's not going to go off that guide, and it only goes 13 units, which is the width of the guide in either direction. Once you do that, name it. In this case, I'm calling it head swivel. And then you want to set through an expression the rotation of this head cube to this square's movement in X. I'll select the head cube, go to Expressions Edit, and I'll set its rotation in Y to head swivels explicit translation in X. You want to put a 0 plus and say OK. Now if I select the square and translate it in X, I should see the head rotating. It rotates in a particular direction depending on whether I go left or right with my slider. If I wanted to change that direction, I could go back to Expressions Edit and make this into a negative. Also, if I wanted it to have more movement, I could change this by multiplying it by 3. Now if I select the square, I should see more movement and in the opposite direction. Okay, now let's look at those two nulls which are going up and down and causing the bend over of the torso. If I select the first one and go to Expressions Edit, you see that I have the explicit translation in Y of this null connected to the depth slider, which is controlling the cube for the chest. You can also see that I'm putting it on as absolute. And what this is doing is whether the chest goes forward or backwards, this null always goes down in Y. The negative sign is causing it to go down, and it's going down every time this slider goes off of 0. I'm dividing it by 4 to make it less, and I'm starting it at 4.25 Softimage units. This is going to change according to your setup. It's also going to change according to the parents. I would just start with a particular number like 1 and then increase or decrease it according to what looks right. If we go look at the other one, you can see it's pretty much the same thing. The explicit translation in Y of this null is being connected to the horizontal slider. It's also absolute, and we've got different parameters to make it go down every time it goes off of 0. Now this effect is layered. Because these are parents to other things, they're affecting all the children underneath it. That's what's causing the effect of the backbone bending. All of these sliders over here are controlling the movement of the chest cube. Let's go take a look at the expressions on this chest cube. As you can see, I have 6 expressions on this chest cube. I've got an explicit translation in X of the cube is being hooked to the explicit translation in X of the horizontal slider. I've got the explicit translation in Y of the cube is hooked to the explicit translation in X of the vertical slider. I've got the explicit translation in Z of the cube is hooked to the explicit translation in X of the depth slider. The rotation in Y of the cube is being hooked to the explicit translation in X of the swivel slider. And the rotation in Z of the cube is being also hooked to the explicit translation in X of the horizontal slider. And the rotation in X of the cube is being hooked to the explicit translation in X of the depth slider. So in other words, it's not only moving the cube, but it's rotating it as well. That's what's allowing the head to follow the rotation of the chest. We can see when the depth slider is going to the right, the cube is not only going forward, but it's also rotating on its x-axis forward. When the sideways slider goes to the left, you can see that the cube is also rotated in Z. When it goes to the right, it's rotating in Z. One other thing you might want to do is label your sliders by getting some text. You probably don't want to make them faces so they won't show up in your render. Also, you probably want to put all your sliders under a single null so you can translate them anywhere you want in the scene. You're going to want an extra front view so you can see the sliders and be moving them while you see your character. Here we have our simple character again. In this case, I've actually added a second character, and the second character has a breathing apparatus on him. You can see that it's allowing him to still do the same backbone motions, but some of the points in the chest are being assigned to some nulls, which are hooked to a curve. So let's go look at what that looks like. To create this breathing apparatus, we're going to get a simple square. I want you to rotate it and scale it so it fits inside the chest. I also moved the center so that the front of the square is actually a little bit forward in the chest than the back. The center wants to be sitting right on the bone that you're going to constrain it to. What we're going to do is we're going to make clusters on each of the points of this square and constrain nulls to these clusters. Before we do that, however, we're going to constrain the square itself to this bone in the chest. So I'm going to select the square. I'm going to do a constraint position to this bone. Then I'm going to do a constraint orientation also to the same bone. Now you're going to have to, before you do this, make sure you go into center mode and rotate the center so it's in the same orientation as the center of the bone. Bones always have their x-axis going straight along the length of them, so you're going to need to rotate that center first. After you do that, go to Shape and Set Clusters so that you have 4 clusters for each of the sides of the square. Then you want to get 4 nulls and you want to constrain object to cluster. Once all the 4 nulls are constrained, place them in a hierarchy under one parent null. Now what you want to do next is add this whole hierarchy of nulls into the envelope for this object. You want them to turn into skeletons so that points in the chest are assigned to these nulls. The next step is that we want to add this cluster of nulls into the envelope for this object. First, cut off the backbone from your envelope. Then, you want to select this bone in the chest and make it parent to the cluster of nulls. Say yes to make it part of the skeleton. Then select the body again. Make sure you're an actor and do a global envelope. And add the backbone back into the envelope. Now points in the envelope have been assigned to these nulls. If you select the square that has the nulls attached to it and scale it, you should see the chest scale as if it's breathing. Incidentally, I've also made the buttons on this chest cluster constrained to points on the chest, as well as orientation constrained to the bone in which they're in front of. This allows them to move with the surface of the object. If you notice when the object is animating that you're getting too much bend in a certain area now, you want to go back and reweight those points in that area so that they're not weighted so highly to the nulls in the chest. To make the chest move when he breathes, it only has to be assigned a little bit to these nulls. I would say 75 to 80% should be assigned to the backbones and the rest to the nulls. The last thing you're going to want to do with this breathing apparatus is add it to your sliders. In this case, I've made an extra slider here, called it breath, and I'm going to connect the breathing apparatus to it. You do it in the same way. In this case, I'm going to connect it through scaling. Inside the expressions editor, you can see that I have the scaling in Y of the square connected to the slider's explicit translation in X. In this case, I named this slider breath. I'm using a 1 scaling, and it's being added to, and I'm divided it by 50. I also, if I go to the next one, am connecting the Z scaling to the explicit translation in X of the same slider. Same coordinates. If I select the slider and translate it, you can see that it scales that area of the chest. I can just go a little bit and it scales it a little bit if he wants to be breathing not so heavy. If he starts breathing heavier, then you can increase it. Then of course you're going to want to save keys in X on that, and then go to the F-curve editor, and then you can extrapolate that into a cycle. If you want to adjust areas of breathing in the cycle, though, you're going to have to freeze the cycle. And then you can tag points in certain areas and scale them up in Y to make him breathe more forcefully in those areas. Now we want to look at another example of layering controls. Here I have the same character that we were working on earlier for the basic rig. In this example, though, I'm adding extra hand bones and then some controls to control the way the wrist goes. We have the same up vector that we used earlier for the hand. I've shortened the hand bone so it doesn't go all the way out to the end of the fingers. It's still constrained to the wrist cube and to the hand null, which is now in the middle of the hand. In addition, I've put bones for each of the fingers as child to the effector of the hand bone. To control the effectors of the fingers in this example, I'm going to use a curve. I've made clusters on each point of this curve, and I've constrained object to cluster each of the effectors for the fingers to this curve. Now to move a finger around, all I have to use the M key and grab it, and save shape keys on this curve. Now the layering of the controls is coming in over here. Here I have the wrist cube like I had in the basic rig. I've made two copies that are child to the wrist cube. And these two copies are controlling the wrist's rotations according to expressions. In this case, I've got an expression on here which is connecting the rotation in Y of this cube to the arm joint's rotation in Z. Basically what this is doing is, when this arm bone rotates in Z to bend the arm, this cube is rotating in Y in order to keep the wrist oriented with the arm. The second cube also has an expression on it. This expression is connecting this cube's rotation in Z to the hand bone's chain roots, explicit translation in Y. I'm multiplying to increase the effect. And essentially what that is doing is, when the wrist moves up and down, this cube is rotating in Z to keep the hand again oriented with the arm. Let's see how that works. If I select the whole thing and then I translate it down, you can see how the hand is rotating. This isn't because the hand null is child to the arm bone like we did earlier. In this case, it's because of the expression. If it goes up, it'll rotate up as well. If I select that particular cube, you can see that it's rotated. If I bend it in the top view so that the arm is bent, you can also see that the other cube is rotating in Y. Now there's an additional expressions that I have on this second cube. There's actually three expressions on it. The main one is the rotation in Z, but there's also a rotation in Y, which I'm connecting to the rotation in Y of the first wrist cube. And the rotation in X I'm connecting to the same cube. So what this is doing is it's connecting the other two rotations for this cube to the first cube. Lastly, I have one more additional cube. This one I've placed as parent to the hand null and to the finger spline, which has the cluster constraints. This cube was identical to the other two, and I've constrained it in position and orientation to this cube. What that does is it keeps it always oriented with this cube, but it's not child to that cube. You get some problems sometimes when you make things children. The expressions don't necessarily propagate correctly down to the children. So in this case, I'm doing it with constraints to an object which is the same, and I'm making that child to the top of the constraint hierarchy. It's kind of complicated, but hopefully you can use some of these in your hand if you need to. In this case, you can see the hand is moving. It's staying oriented with the arm, and we're doing shape animation on the finger curve in order to move the fingers around. Here I have the slider controls for the character Harry. You can see the extent to which you can take this. I've got a series of upper body controls, a series of hips controls, leg controls, left hand, right hand, head controls, lung controls. Let's go and look at how these control the body. Here we've got one that moves the body back and forth in Z. Here we've got one that moves it sideways. Here you've got one that rotates the body and the head. Here you've got the one which rotates it in Z. Here you've got one that shrugs the shoulders. For the hips, you have the rotation of the hips. You have taking the hips and the entire body up and down. You've got forward and backward of the hips. You've got side to side sway of the hips. And you've got rotation in Y of the hips. For the legs, you've got the rotation of the foot, the rotation of the toe, you've got the orientation of the leg. Now I'm doing this by controlling, the slider is actually controlling the Y rotation of the foot chain. And then there's an up vector on the knee, and its X translation is connected to the Y rotation of the foot chain. You also have ones for the head, rotating the head, nodding the head, head back and forth, head side to side, you even have some lung controls. There are hand controls which control the rotation of the hand. This is actually controlling the movement of the null that the hand bone is constrained to. I'm using the same setup in this one where you make the null child to the arm effector, and in this case I'm just moving that null and it's making the hand rotate in various directions. There are also ones in the hand here which rotate the fingers. In this case, I again have the fingers as child to the effector of the hand bone, but I don't have any constraints on the end of the fingers. I'm simply connecting the Z rotation of the finger bones in different degrees to the sliders. I can close several fingers at once by going into multi-mode and selecting them and translating them in X. Here I've global enveloped the arm of Igor the wrestler. What I want you to notice when I animate this is how it deforms. You're getting a lot of collapsing in the joint and other things happening that are undesirable. I want to show you a way of keeping this from happening by using objects as skeletons. We're going to place them in the skeleton hierarchy, and this is going to keep some of this deformations from happening, some of the collapsing from happening, as well as it will allow us to use expressions to make muscle movement. Now here I have the same arm which I've global enveloped again with the same skeleton, only I've added some other nulls in certain areas. If we bend the arm now, you can see that it bends a lot better, and you're getting some muscle movement as well. Now the way you do this is you have to add some nulls in before you global envelope it. In this case, I have several of them here which I've made child to the first joint. I've got one which I named bicep in the bicep area. I've got one named tricep in the tricep area. I've got one called flex, which is in the middle of the arm. And I've got one at the elbow. This one at the elbow is for stability, to keep the elbow from collapsing. All of these are child to this arm bone, so they move with the bone. And they get assigned as skeletons, which means points are assigned to them. On the second bone, I have a forearm null, and I have a null for the hand, since I don't have a hand apparatus for this skeleton. Now, even without doing anything else, by putting these nulls in there, it's going to make the arm more stable. However, if you want to get muscle movement and things like that, you could save animation keys on the particular nulls, but what's better is to put an expression on it. That way it always deforms whenever the joint bends of the arm. If I select the bicep null, for instance, and go to Expressions Edit, we can see that the explicit translation in Y of this null is being hooked to the rotation in Z of the second joint of the arm. The reason you're going to use Y for this instead of using Z is because the parent is a skeleton and its direction in Z is actually the Y-axis. I'm dividing that by 100 to make it not so strong, starting it at -1. If I go to Next, you'll also see that I'm moving it a little bit in X. Again, this is based on the X-axis of the bone, which is the parent of this null. So if we go out and look at that, you can see that when the arm bends, this null is moving a little bit to the left and a little bit out to make the muscle bulge, and so it won't intersect with the forearm. Then when it's moving back, it's going back into place. Let's look at another one. In the forearm, if I go to Expressions Edit, you see that I have the scaling in X hooked to the rotation in Z of the second joint of the arm. In this case, scaling is not going according to the parent, it's going to the object itself. The reason I'm scaling this is again to keep it from intersecting too much with the bicep. It's scaling it down so it doesn't go into the bicep. So this is a pretty good way of doing muscle movement and stabilizing your joints. One other example of using nulls in this way is on the character Harry. You see two red nulls which I've used as part of the skeleton in this area here underneath the arms. This is usually a problem area in that it collapses or gets assigned to the arm bone. If you put a couple of nulls down here, then this area gets assigned to those nulls. You can usually make those nulls child to the backbone. In this case, I've got an expression which is automatically making the nulls go out when he raises his arms and go in when he puts his arms down. This is more natural if you're doing something like a coat, which is going to do that. If I select the null and go to Expressions Edit, you see that this null's explicit translation in Y is being hooked to the explicit translation in Y of another null, in this case, the up vector for this arm. So when the up vector goes up and down, this null goes from side to side. Now the reason for that is, again, it's using its parent's coordinates, and the backbone Y is from side to side. There are various ways of doing facial animation in Softimage. You can do shape animation on the face itself, or you can make clusters and do shape animation on that. However, I'm going to show you another way which uses objects as skeletons constrained to clusters. In this case, you can see a bunch of curves that I have sitting on the face. You can draw them with magnet on the surface of the face. You want to create them in such a way that they follow the muscle movements of the face. If you actually look at an anatomy book for the muscles of the face, they move in a circular motion around the mouth and the eyes, and you also have ones for the forehead. So what I have done here is on each of these curves I've created clusters on the points. You can see that each one of the points on this curve has a cluster on it. And what I've done is I've made those clusters active, and I've constrained nulls to each one of these clusters on each of these curves. If we go look at those nulls, you can see that there are a ton of nulls constrained to all of these clusters on these curves. What I did then was put these nulls under one null and assign the entire thing as part of the skeleton envelope. When you do a constraint object to cluster like this, it is essentially a position constraint. It is not an orientation constraint. In order for this to work correctly when the head turns and the body turns, you have to have orientation constraints on these nulls as well so that they turn with the head. They're going to be assigned to a certain number of points in the face, and they have to turn in order for it to work correctly. So what you should do is make this top null both constrained in position to the head cube as well as constrained in orientation to the head cube. That way when the head turns, everything will turn with it. That essentially converted the nulls into skeletons so that I could control the facial animation using shape animation on these curves. What you can do then is save shape keys for these curves in the negative numbers. And then you can set the interpolation to weighted and hook sliders to the shape weights of each one of those curves. For instance, if I select this slider for the mouth and translate it in X, you can see that it makes the mouth smile. Or the opposite weight of that is to make the mouth go downward. I hook these sliders to the curve in the same way that I did the ones for the body. If I go look at the expression for that, you can see that I have 5 expressions on this curve, which once you save one shape key on your curve, you'll be able to find the shape weights in the F curves. Each one of these shape weights is being connected to each one of the sliders, explicit translation in X. In this case, I'm also dividing each one of these by 13 because the distance I'm moving from 0 on my sliders is 13 units. And I want the full range of the slider to equal 1 on one side and -1 on the other side. 1 in shape weights is a full shape. -1 is the opposite shape. You can see your shape weights by going to F curve select object shape weights. And as you can see, each of the shapes at its full strength is going to 1, and no shape is 0. Negative shapes would be in the negative numbers. So you're going to want to save shape keys for all of your curves. Here I've got ones for the mouth, the cheeks, the left eye, the right eye, the eyebrows. I can combine all of these to make different facial expressions on my character. In each case, all I'm doing is saving X translation keys Incidentally, you're going to run out of room for your sliders after a while when you have a lot for the face and for the body. In this case, I have the facial sliders sitting in the exact same space as the body sliders, only I have the body sliders hid. I've created a master slider on the top that when I select it, if it's at -13, it shows me the facial sliders. If I put it at +13, I see all the body sliders. This master slider is hooked through an expression to the branch visibility of all of the facial sliders and the body sliders. One other thing to note about this facial setup: there's a jaw bone here which was not in the basic skeleton. It's constrained to the head cube and is a 2-joint skeleton and goes out to the jaw. There it's constrained to a null, which is constrained to a cluster on one of these curves. So when the curve shape animates, the jaw moves as well. In this case, you can see the jaw moving with the curve. You can see that the teeth are also moving up and down according to the movement of the bone. They're actually constrained to the null, which the effector of the chin bone is constrained to. If we go look at that expression, you can see that it's just an explicit translation in Y to the explicit translation in Y of that null. One last thing about the setup for the virtual sliders. You're going to want to make sure the virtual sliders are in the hierarchy for your character. This will make it easier when you move things from scene to scene. However, you want to make sure that the virtual sliders are not child to the movement or rotation nulls of your character. You should go get another null and make it parent to all the moving parts of your character and all the virtual sliders and non-moving parts of your character. You also want to make sure that you don't scale the virtual slider hierarchy. Some of the constraints, like position limits, will not reflect that scaling. There are a few ways you can animate your virtual sliders. One is to draw a curve. In this case, I've drawn a linear curve with points directly over the sliders. Then I've gone to shape and set clusters. You can see I have several clusters on this curve already set. Then I constrain the sliders themselves to each one of these clusters. From then, I can shape animate this curve. I can just use the M key and pull points on it. And save key object shape. By saving shape keys like this, I can animate several sliders at once to create different poses. The other way to animate your sliders is to save explicit translation keys in X on the sliders themselves. Now you may notice that I've removed the curve that had the wrists and ankles constrained to it, and I've just created some other sliders for the arms and legs, explicit translation in X, Y, and Z. I can just move these sliders to move the arms and legs around then. And what I've done here is set keys for 4 poses on this character. In this case, at frame 0, I have the neutral pose. At frame 30, I have him pulling his gun. At frame 60, I have him shooting his gun. And at frame 90, I have him crouching. These poses I've set just by saving keys on the limb sliders as well as the rest of the body sliders. Now with 3.8 you can use an additional thing once you've set your keys for your poses. You can use something called actions in the dope sheet. In order to use actions, you have to select the character from the very top of its hierarchy that has the animation under it. In this case, I've got one called Actions Body that if I select it as a hierarchy, it selects all the sliders for the body as well as the body itself and all of the bones. Then we'll go into the dope sheet, and in order to see the actions track, you have to go into Setup and turn on Show Actions. I'm going to also turn on Show Interpolation. Create anchor keys on action creation actually will make it so that the actions don't interpolate between each other, but I want that, so I'm not going to turn that on. Now here is the action track, and you can see that I have some actions already set. In this case I've got pull gun, and it's dragged over the frames that I saved for pulling the gun out. If I want to set a new action for the crouching portion of his pose, I'll just select in the actions track with the left mouse button and drag over the area that I want to set the action for. Then I'll accept that by hitting the right mouse button and it turns white. Then to name it, I'll click it with the white mouse button again and give it a name. You can adjust things in here like what frames it's on, or if you want it to cycle. I'm going to say OK with this. Now the reason actions are useful is because they group a number of keys together to make a pose, in which case I can now copy this grouping by selecting the action, going to copy, and then I'll go paste it and it pastes all of the keys which are associated to that pose. I can get back to the Actions dialog box by right-clicking on this, and I'm going to cycle this 3 times. Now he's shooting 3 times. Then I'll go back to the crouched position by copying that and pasting it to the final frame. Now in the section between the crouch here and the shooting, there's a space, and it's going to interpolate the keys between those 2 actions with a spline interpolation to get a smooth transition. Let's go and see what that looks like. If I bring up a flip book, you can see that the character pulls his gun, shoots once, and then shoots 3 times and crouches again. The third method you can use to animate your virtual sliders is to hook your virtual sliders to a MIDI controller through channels. In order to do this, you have to have a Sound Blaster compatible sound card, and you have to have the Sound Blaster MIDI drivers loaded up in your system. Here in Multimedia Properties, you should see your MIDI drivers, and under Devices you should see the MIDI drivers loaded. Now I'm using a PC-1600 controller as recommended in the Softimage CDs in the training section. In that section it tells you how to set up the PC-1600 and how to upload a file that configures the sliders on the controller. Once you get your controller set up, it's relatively easy to connect it to your virtual sliders. To do this, you want to go to Channel, Channel Setup, so click on New. Load the file called MIDI.exe, then double-click on it. Inside the configuration box, just check Controllers and Both and say OK. When you go back out, you'll notice that you have several new MIDI channels. You want to start using MIDI channel 1. You don't want to use MIDI channel 0. To actually connect one of the sliders, make sure you select it first and then go to Channel, Connection Setup. Then you can connect one of the MIDI channels to the explicit translation in X of your slider. Also, for these particular sliders, you want to put a -13 offset and a scaling of 26. Because our virtual sliders go from -13 to +13, -13 offset is going to make the virtual slider all the way to the left when the controller slider is all the way down. 26 is going to make the virtual slider all the way to the right when the controller slider is all the way up. Now to test that, we'll do a channel, calibration, calibrate. Now you can see if I pull the controller slider all the way up, the virtual slider goes to the right and the mouth closes. And if I pull the controller slider all the way down, the mouth opens. So after you've connected several sliders, as I've done here with the facial controls, you're going to need to be able to select them together in multi-mode in order to do a channel run. So it's best to make a selection set of them that you can click and select them all as one piece. You also want to save an explicit translation keyframe in X on these at frame 1 or 0 or something in order to set the interpolation of these to spline when you start saving inside of the channels. So now I'm going to go to a frame that I want to do some sort of facial animation on, and I'll go to Channel, Channel Run, Frame I/O. You can see that I have the controller sliders evened out. If I move a couple of them up, you'll see them moving and the character will smile in this case. If I want him to close his mouth, I'll move slider 1 up, and I'll hit the middle mouse button to save a key. Then I'm going to slide over to frame 60. And I'm going to make an angry face. And hit the middle mouse button again. Then I'll hit the right mouse button to end that, and we'll go take a look and see what we got. If we go select one of these and look at the F curve, you'll see that it's a normal F curve with spline interpolation. I think you can see the advantage of using this to do your animation. In some ways it's quicker and more intuitive. This concludes the series Realistic 3D Character Development. Thank you for joining me, and I hope you find these techniques useful in creating your own virtual characters.